Hello and welcome to another lesson on electrolysis. Today we would be talking about electrolysis of brine. Brine is the name for a concentrated sodium chloride solution. Brine is used as a preservative and it is used to preserve food items like fish such as tuna chunks and other types of substances as well. When brine is electrolyzed, we get three different products. We get chlorine gas produced at the anode, hydrogen gas at the cathode, and sodium hydroxide solution as well. And therefore, the overall reaction for this electrolysis can be written down as the one you're seeing here. And in this video, we are going to focus on how electrolysis of sodium chloride solution produces these three products and how do we write the equations to show how these are produced after the electrolysis of brine or concentrated sodium chloride solution. Now, the first step is to pass electricity through the sodium chloride solution. And when electricity is passed through sodium chloride solution, sodium chloride breaks down into sodium ions and chloride ions. Sodium ions have a +1 charge because sodium is in group 1. And it reacts by losing 1 electron. And therefore, the charge it has when it forms an ion is +1. Whereas chlorine is in group 7 and it reacts by gaining an electron. And hence, when it forms an ion, it does so by gaining an electron, and therefore the charge on its ion is a -1. Now, we said that brine is a solution. And therefore, it not only has sodium chloride, it also has water. And when electricity is passed through the solution, the water breaks down as well to form hydrogen ions and hydroxide ions. Now, if we see carefully here, we have a pair of positive ions and a pair of negative ions as well. So the positive ions that we have are sodium ions and hydrogen ions. And the two negative ions that we have after electricity is passed through sodium chloride solution are chloride ions and hydroxide ions. Now we're going to first focus on what happens to the positive ions. Now, as there is a pair, there's a competition between the two as to which one of them will stay back in the solution and which one would move towards the negative electrode and get deposited. Now, sodium, being more reactive than hydrogen, prefers to remain in the solution, whereas the hydrogen ions travel to the negative electrode, which is the cathode. And they travel to the negative electrode because opposite charges attract each other. When the hydrogen ions go to the cathode, they change into hydrogen atoms. Now, hydrogen is a nonmetal and it is diatomic. So we cannot just write H in that equation. We have to write 2, and that 2 shows that there are 2 hydrogen atoms together forming a molecule of hydrogen. Now, if we do that, we have to balance the number of hydrogen atoms on both sides of the equation because all chemical equations must follow law of conservation of mass, which states that the mass, total mass before and after the reaction should be the same. So what we do is we write a 2 in front of the hydrogen ions to balance or to make the number of hydrogen atoms 2 on both sides of the equation. Now, on the left, if we look on the left-hand side, look at that left-hand side of the equation, we see that every hydrogen ion has 1 positive charge. But now we have 2 hydrogen ions, and therefore there is a total of 2 positive charges. And to balance these 2 positive charges, and that needs to be balanced because unless that is done, we cannot have a neutral molecule. Okay, so to balance the 2 positive charges, we need 2 negative charges. And these 2 negative charges are gained by accepting or gaining 2 electrons. And because this involves gain of electrons, this is known as a reduction reaction. And this is the half equation that takes place, that shows or represents the chemical reaction that happens at the cathode. Now, focusing on the negative, the pair of negative ions of there. Okay, here we're going to go back to the rule that we have spoken about in the second lesson on electrolysis, changes at the electrodes. At the anode, if one of the ions is formed from a group 7 element, then that ion gets a preference and it gets deposited at the anode. Now we can see that we have chloride ions as one of the negative ions. And chloride ions are formed from chlorine, which is a group 7 element. And therefore the chloride ions have a preference over the hydroxide ions. And what they do is they travel to the anode, which is the positive electrode. Again, because of the reason that opposite charges attract each other. Now, when chloride ions travel to the anode, they try and change into neutral molecules. So, they try and change into Cl, but wait a moment. We cannot write just Cl because chlorine is diatomic as well. So we put a 2 there. And if we do that, as we did with the last equation, we have to balance the number of atoms because all chemical equations must follow the law of conservation of mass. And to balance the number of chlorine atoms, we write a 2 in front of the chloride ions as well. Now, we can see that every chloride ion has 1 negative charge, but on the left we have 2 chloride ions, and therefore there are 2 negative charges on the left. And this needs to be balanced before it can turn into a neutral chlorine molecule. And that is achieved by losing 2 electrons. Because the electrons are being lost, we write them on the right-hand side of the equation. And this equation represents the chemical change that happens at the anode. Because this involves loss of electrons, this is also known as the oxidation reaction. Now, if we talk about the remaining solution, so we can see that out of the pair of the positive ions, the sodium ions stayed back in the solution, whereas the hydrogen ions were deposited at the cathode. So we can strike off hydrogen ions because they have been deposited. So in the remaining solution, we still have some sodium ions. And out of the pair of the negative ions, we can strike out chloride ions because they have been formed at the anode. But we are left with the hydroxide ions that have stayed back in the solution. Now what happens is another chemical reaction, because you can see there's a positive and a negative charge here. So the sodium ions and the hydroxide ions combine with each other to form sodium hydroxide. NaOH is the chemical formula for sodium hydroxide. So the remaining solution consists of sodium hydroxide, and sodium hydroxide is an alkali. And therefore the remaining solution after the electrolysis of brine turns alkaline. How can we check this? Very simple. We can either use a piece of litmus paper. Red litmus paper would turn blue, or we can add 1 or 2 drops of universal indicator solution, and the color would change to blue. And that shows that the remaining solution is alkaline. Now this is all we are covering in today's lesson. And reminding all of you again, please make sure that you complete the recall quiz and the exam question on the electrolysis of brine. Hope this was useful and you have a brilliant day ahead.